Hello, everybody. My name is Nate, and I worked alongside Sandeep, Shubham, and Surabhi on this group project. All right, let's jump right in. So for this presentation, we'll first start out with a quick overview of our data set, as well as discuss some of the packages and overall techniques we use to analyze the data. After that, we'll discuss some data cleansing and pre-processing that was conducted, before moving on to exploratory data analysis and some insights gained from our EDA. We'll then introduce spatial analysis and some modeling techniques and explore their results. And finally, we'll end by highlighting major conclusions drawn from our analysis, as well as propose a few recommendations. So the data we analyzed was housing sales data for King County, Washington, which is the county that Seattle resides in. We sourced this data from Kaggle, which is a website focusing on data science learning and houses a vast library of data sets across numerous industries. Our data set had 21,613 unique observations, or sale records, and 21 variable columns that you can see in the table on the right. The last two columns, square foot living 15 and square foot lot, were added by the original contributor of the data set, after performing k-nearest neighbors with the closest 15 neighbors to the data point. Since this analysis was already done beforehand, we excluded these columns in our project. So we use several Python packages and techniques throughout our analysis. These include, but aren't limited to, pandas, NumPy, matplotlib, scikit-learn for the models, Seaborn, and several more. All right, now I'll turn over the presentation to Sandeep, who will describe the data cleansing and pre-processing steps that were completed.
Thank you, Nate. Hello, everyone. My name is Sandeep, and I'm going to talk you guys through the pre-processing that we've done for a data set. Firstly, data cleaning. We wanted to see if there were any null or missing values within any of our columns in the data set. Lucky for us, there were not any. Then we moved on to see if there were any typographical errors. Although we did not have much categorical data where we could have typographical errors, there was certainly one listing with 33 bedrooms which we ruled out as a typographical error, and we then proceeded to change the number of bedrooms from 33 to 3 based on similar listings with similar characteristics. And there were multiple listings with 0 bedrooms and 0 bathrooms. Now we understand that they might be studio apartments, hence they don't really have bedrooms. But something really odd about this was that there were no bathrooms also. So we decided to play safe and then just assign all such listings with the average number of bedrooms and bathrooms for the whole data set. And going on to the other columns, they were certainly outliers, but nothing that we could rule out. For example, the price was the least priced listing was $75,000, whereas the highest priced listing was in excess of $7 million. But that's just how real estate works. And coming to the square feet lot, there was one lot with over 307,000 of square feet of the lot size. Now, as we understand in the real estate business, lot size can just be the side of a cliff on which the property sits on, or it could be a vineyard and the house sits on one corner of the lot. So we could not really rule this out because this really adds to the price of the house. And the other outliers were in a similar way. We couldn't rule them out. We deemed them necessary and that they contribute towards the price of the house. Now, as I mentioned earlier, we did not have much categorical data in our data set, so we proceeded to make our own columns and for categories. For example, we took the condition of the house, which was given as numbers 1 through 5. Now we assign categories to them, 1 being very poor and 5 being very good, 3 being the average. and renovation status of the house. Uh, in our data set, if a house was renovated, we only were shown the year in which it was renovated, and if it was not renovated, it was just a zero. So we took this information and then we proceeded to categorize them into two categories: renovated or original. And all the houses with had zero in the original column were categorized as original. And we there were around 70 unique zip codes into which over 21,000 listings were categorized into. So for future analysis and visualizations, we thought it might be easier if we divided the 70 zip codes into four zones or sectors: A, B, C, and D, with with each zip code having around 17 to 18 zip codes. I'll hand over to Surabhi and Shubham. They will guide you through the EDA and visualizations we've done for our dataset.
Thank you, Sandeep. I'm going to explain about EDA we have done on our dataset. The main purpose of doing exploratory data analysis was to understand the data and to gather as many insights from it with the help of visualization. For the visualization purpose, we have used scatter plot, histograms, correlation metrics, and heat maps. Now let's take a look at the univariate analysis of our dataset. The target of this analysis is price of houses in King County. On the left-hand side, we have a histogram of housing prices. From the histogram, we see that the price distribution is highly right skewed, and the highest frequency is for houses within the price range of $200,000 to $600,000. On the right-hand side, we have the box plot for housing prices, and from the box plot, we see that there are many outliers, and these are because of the luxury homes with the high prices. Now let's take a look of the histograms of the bedrooms and bathrooms. On the left hand side, we have the histogram of bedrooms, and we see that the most of the houses have 3 to 4 bedrooms, and 1 and 7 being the lowest. From the histograms of bathroom on the right hand side, we see that the values are unusual, though most of the houses have 2.5 bathrooms, and it is possible to have half and quarter bathrooms. Another feature in our data set was a square foot living, which gives the total area of the total living spaces of the houses in the square foot. And from the histogram of square foot living, we see that there is a long tail on the right side, as we might expect, which also suggests that there are houses with the large total area. On the right hand side, we have the histogram for grade variable, as building grade represent the construction quality. From the figure, we see that the grades vary from 1 to 13, where 1 to 3 indicates short of construction and design, and 7 indicates standard level of construction and design, which is the highest in this dataset, with a count of 8,081, and 11 to 13 indicate high level of construction and design quality. Now let's take a look at the few other variables in our datasets, which is renovation and view. On the left-hand side, we have a histogram of renovation. We see that out of 21,613 houses, 20,699 houses never underwent renovation, which is a high number. And also the rest, which is 914 houses, were renovated over the period of time. On the right-hand side, we have histogram for the view column. We see that around 90% of houses have zero view, and there are very few houses that have an excellent view. Now let's look at a bivariate analysis with respect to price. On the left-hand side, we have a box plot of grade versus price. And from the box plot, we can infer that there is an exponential curve indicating increase of house price with good grade of house, which means as the construction quality increases, house prices also increases. On the right-hand side, we have a box plot of bathroom versus price. And from the box plot, we can infer that if the number of bathroom increases, house price also increases. And we can see that there is an increase in the values of the bathroom and also with the values of the price. Another variable in our data set was the zip code. And if you look at the box plot of the zip code versus price, we see that the zip code does not have a much significant impact with respect to the price. In total, we had 70 unique zip code in the data. So that's all from my side, and the rest of the EDA part will be explained by Surbi. Thank you.
Now, let's look at the scatter plot showing three variables. Y3, along x-axis we have one variable, along y-axis we have the second variable, and the third variable is added by coloring the dots. These dots represent the square feet living feature of the house. Now, for example, where are the larger houses? Yes, we can spot it here. This color code is yellow, so this indicates that there are very minimal houses which are large. Next, most of the houses are below 4,000 square feet living. These are indicated by blue to violet color coding. Also, we cite that highest number of properties are in the northwest region of the country. So there are many things that we can conclude from the scatter plot. Next, this is a scatter plot of latitude, longitude with grade. Here we can locate the houses built with average or higher quality materials. As we see, most of the houses of the grade are between 7 to 9, or we can say 7 to 8. These are represented by color coding of green, a shade of green. Next, now we will look at the feature of waterfront. This is a Boolean variable to indicate whether the house had a view of waterfront or not. Looking at this scatter plot, we spot majority of the houses do not have a waterfront, and these are indicated by the orange color. Next, this is a heat map of correlation matrix which displays a table of correlation coefficient between the two variables. So the two variables will be these versus these. The correlation coefficient range from -1, which indicates a perfect negative correlation, to a +1, which indicates a perfect positive correlation between the two variables. From this table, we get to know the statistical significance of the features in our analysis. Now here we see that the shades of brown or red show a positive strong linear relationship between the two variables, and the ones which are seen by blue color, so these show a weak relationship between the two variables. Now, since price is our target analysis, let's look at the relationship with respect to price. So as we see, price has a weak relationship with, we can say, floors, and then we can also say waterfront, then the square foot basement. So price has weak relationship with these features. However, it has a minimal relationship with the year the house was built. We see it's very small correlation coefficient value 0.054, and also price has a minimal relationship with the zip code. So these factors do not show a much statistical significance. Now, let's look at the ones which are strongly correlated with price. Here, so this is a separate heat map which we are trying to show the moderate to strong relationship of different variable with price. From here, we can say that the strong predictors for increase in house price are square foot living and the grade of the house. More live we also we can say, right, like the more living area the house has, it logically implies to a higher price. And yeah, we are almost done with the explanatory data analysis. Now Sandeep will talk about the spatial analysis and the KNN model.
Hi everyone, this is Sandeep. Following up on the EDA and visualizations of Surabhi and Shubham, we actually have some interactive heat maps that we got to play around with. So the heat maps are using the Folium package, and since we have the latitude and longitude of each listing, it just makes it easier to plot them on a map. And the overlay for this map on top of the latitude and longitudes is actually the price of each listing. So Folium actually clusters each listing by the proximity between them. So it automatically, the clusters are made automatically based on the zoom levels. So if you zoom in lower, the clusters get wider, and each cluster then is represented by the price in colors, red being the most expensive listings, to blue being the least expensive, yellow and green are in the middle. And if you zoom in to the ground level to each individual listing, you can actually see that it is represented in blue because there is no cluster and nothing to compare it with. But if you zoom out to the desired level, then you start to see the price depend according to the price and the color. Moving on, we have another map. Now this is a little different from the heat map that we have seen before. Using the same Folium package, Folium also clusters them depending on the zoom levels. So if you zoom in lower, and it actually highlights the sectors that it has been zoomed by a blue outline. And if you click in to each circle, it opens up to more clusters. And if you go down to the base level, each individual listing is again represented by a blue marker, and hovering around the marker gives you basic information like zip code and total price. And if you click for more, it shows you the price per square foot and the condition of the house. Now this is not fixed, and we can actually change what information you want to be shown on the cluster when you click for more. And also we think that these two heat maps are a very cool way and also a very easy way of just locating your next house. And not only does it show you the features of the house, but also you can see what neighborhood it is in and the nearby amenities, like is it located near a park, is it located near a lake, and then the proximity to highways if you have to drive out of town. So this is a really good way of showing them rather than the basic Excel file. Moving on, here we have a basic bar chart of the condition category of the listings. As you can see, roughly 65% of the listings belong to the average condition, and they are a relatively low or almost negligible amount of listings which are in the very poor category or the poor category. And this relates to our future KNN model. We also see the color map of the same similar listings of the condition category of the listings. And you can see that zip code does not actually play or confine, in fact, the listings to the conditions. So the average condition listings are scattered all throughout the King County, and as we spoke earlier, they are negligible amount of listings in the poor or very poor category, and hence we might not be able to spot them in fact here in the color map. And one thing to note is that the year built and the condition of the house have a negative correlation, which is to say that if the house is really old, then the condition becomes poorer and poorer, which is quite logical. Moving on, we actually have a KNN, or the K nearest neighbors algorithm. We try to predict the condition of the house based on the original categorization, which is in numbers 1 to 5, 1 being very poor and 5 being very good. Our training and testing data set was done in an 80-20 split, and the rows were selected randomly. And the accuracy of our KNN algorithm was around 62%. Again, this might not seem like a very good number, but one thing to note is that since there are a very low number of houses in the poor category, our training data set failed to pick up any such listings, and then by default the precision was set to 0. Now this contributes to a slightly reduced overall precision. Now running through all the columns in our classification report, precision is actually the precision with which our model can correctly predict the condition of the house, 1 to 5. Recall is the ratio of all outcomes that were predicted correctly to the sum of outcomes that were predicted correctly, and to the sum of correct outcomes that were correct but not predicted correctly. And F1 score lies between 1 to 0, 1 being a very good score and 0 being otherwise. Prediction support is actually the number of such listings that our data set or training set rather has picked up. For example, we only managed to pick up 4 listings with a condition of 1, and which is too small, hence the precision was set to 0. So overall, the precision can really be improved, but with having more information regarding the housing data set. And if you look at the graph, the training and testing data set accuracy kind of levels off at around 68%. Is not a really great number, but again, there are factors beyond our control which could have led to this number. I will leave you with Nate for our final conclusions and recommendations.
Hey everybody, it's Nate again. So since we wanted to understand the trend in housing prices and which variables are the largest influencers, we decided to create a multiple linear regression model that could be used to predict the price of a home. We first eliminated the ID, date, zip code, latitude, longitude, square foot living 15, and square foot lot 15 columns, since it would be hard to interpret the effect these have on predicting the price of a house. And with the data frame consisting of the remaining rows, we randomly assigned 80% of our observations as training data and the remaining 20% as testing data. And before getting into the model results, I want to briefly touch on data scaling. So we tried to scale the variables using standard scalar, scaling by standard deviation, and then again by min-max values. And when we ran every version of the scaled data through the model, and the results, mainly R squared and the beta coefficients, did not really differ from model to model, including the model with unscaled data. So for ease of interpretation, we decided to report results on the model with unscaled data. As you can see from the output, our response variable, price, is highly sensitive to the waterfront, view, and bedroom columns, and not as sensitive to the square foot lot, square foot above, square foot below, and year renovated columns. Looking at the p-value, which measures whether the predictor variable has any correlation and an effect on the response variable, only the year renovated column is insignificant. And by now, I'm sure we're all able to interpret beta coefficients, but just to reiterate, if we increase the number of bedrooms by 1, we'd expect a negative 4.066 times 10 to the 4th power decrease in housing prices. And according to our R-squared value, we're able to explain 65.2% of the variation in housing prices with the variation of the predictor variables we used in the model. And our adjusted R-squared value, which increases the model only if a new predictor variable enhances the model above what I guess would be obtained by probability, is only slightly lower at 65.1%. However, while only explaining 65.1% of the variation in housing price seems low at first, and we'd like it to be higher, it doesn't necessarily mean that our model is not a good fit. It could be due to the fact that real estate is an emotionally driven industry, and since human emotions are such a large factor in determining what house someone buys, we could assume that real estate prices have an inherently greater amount of unexplainable variation. But our suggestions would be to either, one, include more predictor variables to try and improve our adjusted R-squared, or two, we could focus on beta coefficients to determine which one that housing prices are most sensitive to. So in addition to linear regression, we also used logistic regression to try and predict whether or not a house was renovated or not. So we again deleted the columns we did not want to use for prediction and used a random 80% to 20% split for the training and testing data, just like we did with linear regression. And after fitting the model, our beta coefficients can be seen in the table on the left. Our model was able to correctly predict 95.74% of the outcomes in our testing data. Based on this accuracy, we created 3 hypothetical houses and used the model to predict the probability of each being renovated. The predictor variable details as well as their probabilities are listed on the table on the right. We can see that there's a high probability that all 3 of these houses were not renovated. So what can we conclude from our analysis? Well, the construction quality of the house and the square footage of living space are the variables most highly correlated with housing prices. Along those same lines, as the condition of a house improves and as we increase the number of bathrooms, we typically see an increase in housing prices, which should make sense, right? And houses with views tend to command higher prices, yet the age of the house does not seem to have a significant impact. And as far as models go, our logistic regression model was about 96% accurate in determining whether our test data was renovated or not. However, our multiple linear regression model might benefit from additional variables in helping explain the variation in housing prices. And finally, we get to the so what of our analysis. How can we put what we've discovered into action? Well, we suggest that because of the outliers in housing prices, we might not be accurately describing the average house in King County. So we suggest that when new data is collected, it's split between a luxury group and an average group, depending on some threshold specified by the next interested parties. Also, as we touched on the previous slide, we recommend that when the next group collects data, they include additional variables that might include facilities, the neighborhood rankings, crime rates, whether the house is in an HOA governed community, etc. These should help explain more of the variation in King County's house prices. And that's the end of our presentation. If you have any questions, please reply to our link in the discussion thread and we will be happy to respond. Thanks everyone for watching.